Hey guys, my name is Arab Jaiswal, and today we're going to be doing thermal energy. So first we need to know what thermal energy is. Thermal energy is nothing but heat. And I might be lying if I say this. Well, technically what I meant to say was I'm not lying because there is no such thing as cold. Okay, so what I mean by there is no such thing as cold is that it means that basically there's less thermal energy in the object, and there's no such thing as cold scientifically speaking. If we're scientifically speaking, then there's no such thing as cold, but sure, when we're like theoretically speaking, generally speaking, in regular conversations, we'll be saying that oh my god, it's cold out. But if we're scientifically saying something or explaining something, then we're not going to use the word this term. We're going to use thermal energy. Now, the reason is because thermal energy is getting extracted from the object, making the item have less thermal energy, if that makes sense. So, the thermal energy is being extracted because of is being extracted and thus making it have less thermal energy. Now there are three ways that heat moves. That is conduction, convection, and radiation. Conduction is when heat transfers through a direct contact, meaning that if I'm cooking something and I'm cooking with a metal spatula, then uh, when we turn the stove on, it's going to transfer the heat to the pan, which is radiation, and I'll come to that when I get there. And then there is conduction, which happens when the metal spatula is like if you're stirring the item, then you can feel the heat because of conduction, which is traveling through direct contact. Now, there's also electricity conductivity, heat conductivity, other types of conductivity, but because we're doing thermal energy today, we're going to be focusing on heat conductivity. So next up we have convection. So convection is the movement of a heat by fluid such as water or air. Like say that I am camping on a nice summer day. I'm camping. And let's say that the fire is so big and it's producing so much energy, like so much thermal energy, that even if I stand like a mile away, I can still feel the heat from the the fireplace. So that is because of convection, because the heat is moving is through the air going through your body, which makes you feel the convection. That's what convection basically is. If you're camping and the flames are so strong that you can feel it from a mile away, a kilometer away, that's what convection is. Pretty simple, not that hard. Then we have radiation. Radiation is heat that is transferred through waves, rays, or particles. Now, let's use that same camping example that I used for convection. So, I can feel the heat from 1 mile away. Now, radiation is when I can feel it from a short distance. I can feel it from a short distance, but if I'm from a far distance, I can't really see it. I can't, okay, what am I saying? I can't really feel the heat. But from a far distance, I can't feel the heat because there's no convection for some reason based on the environment that you're living in. We're just taking an example. Just deal with it. No need to make counter arguments. Back on track. So if we're on radiation, it's transferring through waves, rays, or particles, but it doesn't necessarily have to be from like far distances. It can also be from close distances. It's just radiation is like a variable because it travels from waves, rays, or particles. So depending on the wavelength, it'll give that much heat. So like let's say if the fire's wavelength is fairly short, we'll just say that, because if we stay away like 1 mile away, I'm pretty sure we might not feel the fire. We might not, but for the sake of the video, we're just going to pretend that we're not feeling it. So radiation is just a variable, like the sun. That's like a very long distance. That's like millions of miles away, and we can still feel the heat because of waves and rays or the particles. That's radiation. So now we're going to look at a lava lamp, which I'm going to draw, and no judgments on my drawing, please. So first, let me just scroll down a little and let me draw my lava lamp. Okay, so this is my lava lamp. Like I said, no judgments on my drawing, will ya? So over here, we have a light bulb. A light bulb. That's my light bulb. Like I said, no judgments. Okay, no, honestly, that's a bad light bulb. Let me draw a different one. Okay, yeah, a light bulb. Okay, we'll just deal with that. Just deal with it, man. It's a light bulb. It's a light bulb. Okay, it's a light bulb. Then we have the glitter. We can say the glitter, where the particles are flowing to the top, and they're going to the bottom. These are all. So now using radiation, convection, and convection. What am I saying? Convection and conduction. We're going to identify what this is. So from the light bulb to this part is radiation, because it's traveling through waves. That's radiation. Now, conduction is going to be like, let's say this is our hand. This is our human hand. And it's touching the lava lamp. So that's going to be conduction, because obviously it's producing heat. And convection is going to be throughout all of the lava lamp, because no matter where you touch in the lava lamp, your hands are always going to feel heated. And you might see that particles move up and down, and that's because of the pressure. So like if there's like high pressure, then there will be like more dense or less dense. But yeah, that's something later that you'll learn. But for now, this is how conduction, convection, and radiation works in a lava lamp. Now, let's say that we're cooking. Okay, let's take the example of me cooking. So here we have our flames. And then here we have our pot. And I am making pasta, let's say. I'm making pasta. These are my pasta noodles. And then here's my water. And then here's my metal spatula. Yeah. Okay, that's a very bad metal spatula, but let me just draw it clearly. Okay, yeah, that's better. So now that we have our noodles and our metal spatula, so here the radiation is going to be from the heat waves, because it's again traveling through waves, and it's touching the pot, which is making the whole pot heated. So that's what's radiation. Conduction is again when the hand is touching the spatula, you're going to feel the heat because the pot is hot. And then convection is like if you, once the water is starting boiling, you can feel that water is like, if you touch the water or if you touch the pan outside, you'll feel that's hot. So that's convection, conduction, and radiation. So these are how thermal energy works, and I hope you learned a lot from this video along with the examples. And make sure to like and subscribe to learn more. Bye. Hey guys, my name is